Hello and welcome to the video of proportions. In this video, we will learn how to recognize proportions mathematically and in everyday life. And finally, answer that question, what does it mean to be proportional? Well, the definition of proportion states a statement of equality between two ratios. But let's look at the word for a more in-depth understanding. The first part of the word is pro. And pro means to be in favor of a course of action. But what course of action are we so in favor of? And that is simply scaling. The second part of the word is portion. Now, portion is what you have. This could be a part of a whole, an amount, a section, or a piece. So proportion means that we are scaling something that we have. We are scaling a part of a whole, an amount, section, or piece. And it seems to be something that we're definitely in favor of. Now, scaling means to enlarge, shrink, or stay the same. A good example would be a magnifying glass. Now, in the magnifying glass, you can only see a part or a certain amount of the whole world. And this amount is scaled up so you can see it clearly. So small little ants become larger and much more visible. And proportions are everywhere in our world, and we can't seem to get away from them. Even in worlds that we create, we see that proportions or proportional relationships are through them all. Let's look at the world of a famous Italian plumber and how proportions help him go through his adventures. Let's look at the world of Mario. There are items in the Mushroom Kingdom that can enlarge him or scale him up. We see this several times as he's battling the obstacles to get to the princess. Also, when Mario is hit, he is scaled down. So, Mario is kind of like a proportional Rambo going through the levels saving the princess through proportionality. When you have an object and you multiply it by some number to enlarge, decrease, or even if the object stays the same size, well then that number is called a scale factor. Now ultimately we're asking ourselves which types of numbers increases or decreases an object. Ultimately what will be? If you use a scale factor that's less than 1, like a fraction, 1/4, or a decimal, like 35 hundredths, or even a percent that's less than 1, like 9%, then your object will shrink. If you use a scale factor that is 1, then your object stays the same size. And if you use a scale factor that is greater than 1, like an improper fraction, like 3/2, a decimal is greater than 1, like 1 and 25 hundredths, or a percent that's over 100%, like 316%, or even a whole number that's greater than 1, like 7. Then we see our object gets larger. So a scale factor greater than 1 enlarges an object. If it is 1, it keeps the object the same size. And if it's less than 1, it shrinks an object. Well, let's look at some objects and see what type of scale factor best fits them. We have a guy doing laundry. He is seen to have shrunk his shirt. So the scale factor used will be greater than 1, less than 1, or equal to 1. Well, that's correct. It will be less than 1. And the next image is a picture of a mirror, which shows us an identical reflection of whatever we see in it. So, would the scale factor be less than 1, greater than 1, or equal to 1? Well, that's correct. It will be equal to 1. And this magnifying glass will have a scale factor from a number that's what? Correct. Greater than 1. But how does proportionality work in math and other elements? Let's say like in a table or a graph. Well, there are two main characteristics that we need to remember when we're looking at a graph to determine if it is proportional. The first thing is that the table must include or have the points 0, 0, the origin points. The second characteristic is that each independent variable of x must be multiplied by the same scale factor to produce the desired output of y. So 0 times 6 is 0, 1 times 6 is 6, and 2 times 6 is 12. All were multiplied by the same scale factor to give our output, so our table is definitely proportional. For a graph, there are two characteristics as well. The first is the same as the one for tables, is that the line must go through the origin or the line must have the points 0, 0. Same thing. So, and the second characteristic is that the line must be straight or linear. So when we look at these different lines, let's look at the red one. The red line is a linear or straight line. However, it does not go through the origin. Therefore, it is not proportional. The next line we'll look at is the green line. The green line is a linear or straight line. However, it is still not proportional because it does not go through the origin. The orange line does go through the origin. However, it is not a straight or linear line. The only line that is straight and goes through the origin is the blue line. Therefore, the blue line is proportional. Now, what if we have two ratios that are set up as a proportion? How do we know or can tell if this proportion is proportional? Well, one way we can figure out is by doing the cross product, and the other is by reducing the ratios to simple form. So let's do the cross product. So that's 30 times 10, that gives us 300. And 20 times 15, well, that also gives us 300. So seeing that our cross products are the same, our proportion is proportional. Well, let's try the second way. Let's reduce the ratios to simple form. So 10/20 reduced down to 1/2, and 15/30 reduced to 1/2. Seeing that I got an equivalent fraction of simple form, my proportion is proportional. Well, let's look at the problem. Problem number 1 states, Joe can do 10 multiplication problems in 5 seconds. At this rate, how long would it take Joe to do 2 multiplication problems? So we can see our ratio given by the problem, which is 10, and we'll label it multiplication problem over 5, and that's seconds. Now, at this rate, how long will it take Joe to do 2 multiplication problems? So let's reduce this ratio into simple form. And we divide by the greatest common factor, which is 5. Our new ratio is 2 to 1. 2 multiplication problems for every second. So we just learned how long it will take Joe to do 2 multiplication problems. And we found the unit rate. And the unit rate is when we have a ratio whose denominator is a unit of 1. So it would take Joe 1 second. Part B says, create a table of values showing how long it will take him to do from 1 to 5 multiplication problems. Then graph the points on the table on the coordinate plane. Well, if 0 seconds pass, Joe would have done 0 problems. And if 1 second passed, as we already calculated, then Joe would do 2 problems. Well, the scale factor seems to be multiplying by 2. So if we multiply all of our independent variables by our scale factor 2, we should get the number of problems Joe completes. 2 times 2 would be 4, then 6, then 8, then 10. So now we completed our table. So let's complete our graph. The horizontal axis is always the x-axis, and the vertical axis is always the y-axis. And we'll put in our numbers. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And right here will be our origin. Now let's graph the data. When 0 seconds pass, 0 problems are completed. When 1 second pass, 2 problems are done. 2 seconds, 4, so on and so forth. Now, let's put it on line. So let's determine if our graph of our points is proportional and if our table is proportional. Well, our table needs to have 2 characteristics. One, it needs to have the points or origin points 0, 0. So we see that it does. And 2, it needs to be multiplied by the same scale factor. And it is. So our table is proportional. And our graph needs to go through the origin, and it does, and it needs to be a straight line, and it is. So our graph is proportional. And part C, what is the unit rate? We already calculated that, and that was 2 math problems every second. Checking your understanding. Answer the following questions for notes. This will definitely come up in your class. So number 1 reads, define in your words, what is a proportion? Provide 1 example. Number 2, explain what happens when a scale factor is greater than 1, less than 1, and equal to 1. Number 3, what are 2 methods to show your proportion is proportional? And number 4, explain the characteristics of a table that is proportional. And number 5, explain the characteristics of a graph that is proportional. Well, thank you for watching our video over proportions. And remember, math is simply making amazing thoughts happen.